Hey everyone, this is an examples video on the fundamental theorem of calculus, just the first part, and I'll just jump right into the examples. So these are the three examples that I'm going to cover, and this is how we're going to do it. So we're going to first evaluate the integral and then differentiate, and then we're going to compare that to just differentiating the integral directly. So I've listed out the three examples here, so if you want to jump around in the video, you can do that, or you could use this as like a way to quiz yourself. So if you want to pause the video here and then just quiz yourself to see how well you do, that's another way that you could consider using this video. All right, so let's jump into it. So for our first example, so I'm going to do this the first way. So I'm going to evaluate the integral, then differentiate. Okay, so what I want to do then is I really want to actually ignore for this first part. I just want to ignore this first part. And I'm just going to straight up evaluate this. So I need to find the antiderivative of, let's see, so the antiderivative of sine t, which is negative cosine t, and now I have to evaluate this from 3 to x. So now basically what I have to do by using the evaluation theorem of the fundamental theorem of calculus, I basically just plug these in. So this will turn into then negative cosine of x minus negative cosine of 3. And so you can see that becomes plus, right? Okay, so here's the answer I got by integrating. Now what I want to do is I want to differentiate this. So I'm going to just straight up differentiate this result. And so notice this cosine of 3, so this is just a constant really, so that's going to fall out. So I just really have to take the derivative of this. So this will ultimately equal just sine of x. So that would be the derivative. Okay, so there's all the work to get to that. So this ultimately equals sine of x. And now if we do this the other way, so the other way would then be we want to differentiate the integral directly. And so that's really now relying on the first part of the fundamental theorem of calculus, which I've got here for you. And I've got a whole video where I break this down and explain everything about what this means, but I'm just going to just jump right into the part that I actually need to do this problem. So this last line here is really telling me what to do. So as long as I'm kind of in this format where I've got a number here and x here, if I want to take the derivative of this, I can really just plug in x. So what that means then for this problem is that makes this nice and easy peasy, in that I can just say that this just equals sine of x and I'm done. And so that's really it. It's really that simple. So if you compare that to what we did in the other one, this was like a lot more work to get to the same answer. Now, perhaps what I should do just to make sure that you're all good to go here, I will just show you in case you're rusty on anything. Here's a list of all the antiderivative formulas. So you can feel free to pause the video and write these down. So these are things that you should already kind of know, but if you're working through some of these and you've forgotten them, you can have these just written down next to you. Okay, so let's keep going. So doing the next one, so we're going to do the same thing. So first we're going to evaluate the integral and then differentiate. So if I take the antiderivative of 2t, that's going to be t squared, and then I need to evaluate that from 1 to cosine of x. And so then I can just plug that in. So this will become cosine squared x minus really 1. Okay, so now I'm going to take the derivative of this, and so now I have to use the chain rule really. So this becomes 2 cosine x, and then times the derivative of cosine is going to be times negative sine of x. So I guess ultimately this will equal negative 2 cosine x sine of x, and that's because when I take the derivative of 1, this just drops out, so I'm just left with this piece here. Okay, so now let's compare that to using the fundamental theorem of calculus. Now there is a little bit of a twist with this one. Notice that this is not x, this is cosine of x. So the issue here then is if this is anything else, if this is not x, then really what we have here is we really have like the composition of functions, right? So instead of having x, this is cosine of x, so this is kind of like the innermost function. So we're actually going to be using the chain rule here. So I'll show you how this works. So to take the derivative of this, first you're just going to plug in. So normally you would plug in x, but since we don't have x, you're going to plug in cosine of x. So I'm going to plug in cosine of x, but then I have to multiply that by the derivative of the cosine of x, which is negative sine of x. So ultimately this equals negative 2 cosine x sine of x, which, hey, that's exactly what we got before, right? Just much faster. So everything checks out. Okay, so just one more example here. So we'll do the same little song and dance. So first we're going to evaluate the integral and then differentiate. So if I evaluate this integral, so let's see, this will give me 5 over 4 t to the fourth, let's see, minus sine of t. And now I have to plug in the limits of integration. So when I do this, so we just want to be careful. So this becomes the square root of x to the fourth. So this really would simplify then to just x squared and then minus the sine of the square root of x. And then I'll subtract off 5 over 4 times the fourth root of 4 minus sine of 4. Okay, so here's everything that I'm left with in this case. So now I have to take the derivative of this, and so really we know that this second part, this is all just constant. So since this is all constant, I'm not even going to write it down. I just want to take the derivative of this part because maybe I'll just note that here. So dx of this is 0. So I'll just note that there. Okay, so really what I have to do now is I have to take the derivative of 5 over 4 x squared minus sine times the square root of x. So this is going to equal, let's see, this will be 5 over 2x minus cosine times the square root of x times 1/2 x to the negative 1/2. Okay, so that's everything that goes into that one. So now let's, and I'm just going to leave this as is. I think this is probably fine. So now what we want to do is we want to differentiate the integral directly. So to do that, I have to use the chain rule again. So I've got 5 times the square root of x, so all of this to the third. So instead of writing it like this though, I just want to write it as one rational exponent. So I'm just going to rewrite this as 5x to the 3 over 2. Now when I do that, I do have to also multiply this by the derivative of the square root of x because we're using the chain rule here. So I've got this. And then minus cosine of the square root of x, and then once again I have to just multiply that times the derivative of the inside function. Okay, so now let's just go ahead and clean this up. So this becomes 5 over 2, add the exponents, so 3/2 minus 1/2, this becomes 5/2 x minus, so I'm not gonna simplify the second part because this will just help me to make the point that I need to make. I could simplify this, but this is exactly the format of the answer that we left for what we did here, right? So I just wanted to convince you of that. So a lot of times when people learn this, when they learn the first part of the fundamental theorem of calculus, they're kind of like afraid in some ways to like use this because it's confusing and it's weird. And so people get very nervous about trying to use this method. But hopefully you can see now by looking at these examples, this just takes a long time. So I know that this is kind of weird when you're first getting used to it, but if you practice it enough, it kind of all starts to make sense and you can trust it, right? So it's actually faster and it's much faster than going the other route. So I have another video on just more examples like this if you want to see more examples. Otherwise, that'll cover this one. So thanks for watching.